For introduction, this study presents a comprehensive statistical analysis comparing the fat content of two food categories, bread and snacks. To achieve this, the study employs several methods. Estimation of means for two populations using a t-distribution test is used to estimate the mean difference of fat content in bread and snacks. Hypothesis testing is used to compare the mean fat content between the two food groups. The proportion of items with high fat content between bread and snacks is compared by testing the hypothesis that the proportions are equal. Finally, a chi-square test is used to determine if there is a significant differences in the distribution of fat content categories between bread and snacks. By employing these statistical methods to analyze fat content alongside protein and carbohydrate levels, these studies seeks to uncover patterns and differences that may not be immediately apparent, with potential implications for public health, the food industry, and individual dietary decisions. For population and sample, the population for the study comprised various types of bread and snack products available in the market. The sample specifically includes 13 different bread items and 13 different snack items collected from Taman Batra, Tanjung Maling. The selection of these samples was based on their popularity and availability, ensuring a representative mix of commonly consumed products. The sampling process involved gathering data on the fat, protein, and carbohydrate content of each selected item. The data was recorded and organized into two main categories, bread and snacks. This categorization allowed for a focused comparative analysis, enabling us to draw meaningful conclusions about the differences in fat content between these two food groups.
Next, for instrument, we collect the data of snack and bread in terms of their fat, protein, and carbohydrate contents. First objective is to estimate the mean difference of fat content in snack and bread. First, we will use the manual way. The step is, we let x1 bar and x2 bar be the mean of the content of snack and bread respectively. And then by using the formula of mean, we will get x1 bar equal to 6.9077 and x2 bar is 8.3308. And then we will calculate the sample standard deviation by using the formula. And then we will get S1 equal to 3.1221 and then S2 is 5.8247. Since the sample of bread and snack are small, which is both 13 for each of the categories, then we will use t-distribution test. Also, we assume that the standard deviation for snack and bread are equal, and we assume that the fat content in snack and bread are normally distributed. Since the standard deviation is unknown, then we replace it by full sample standard deviation. Then we get 4.6730. Next, we will calculate the estimator of standard deviation by using the formula. Then we get 1.83. And then confidence level at 95%. Therefore, since it is two-tailed, then alpha over 2 is equal to 0.025. And then for the degree of freedom is 24. Thus, the p-value is 2.064. Next, we will calculate the confidence interval. For mu1 minus mu2 is negative 5.206 to 2.3599. So in conclusion, with 95% confidence, we can state that based on these two sample results, the difference in the mean of fat contents of snack and bread lie between negative 5.206 and 2.3599 grams. Because the lower limit of interval is negative, it is possible that the mean fat content is greater in the bread than snacks.
Now to estimate the mean difference using SPSS, firstly, in the first column, input our data, which is the fat content in snacks and bread. In the second column, put in if it's snack or bread. And then in the variable view, for the first column, name it as anything. I name it as fat content, the type is numeric, and the scale and the measure is in scale. Second one, I just name it as group, the type is string, and the measure is nominal. Now click analyze, compare means, and independent sample t-test. Okay, put the fat content under test variable, okay, put it, and put the group and the grouping variable. Then click on define groups. Group 1, put in snack, and group 2, put in bread. Continue. Make sure the options is 95%. And then click OK. You can see the group under group statistics. You can see the mean and the standard deviation for snack and bread. And under independent sample t-test, look at equal variances assumed and 95% confidence interval. And this is the confidence interval, which is between negative 5.2 and 2.36. So this is how you use SPSS to estimate the mean difference.
So we move to second objective, which is to compare mean difference of fat content in bread and snack using hypothesis testing in two population small independent sample. So we need to know the hypothesis, which is for the null hypothesis is mu1 minus mu2 equal to 0, and alternative hypothesis is mu1 minus mu2 greater than 0. So since the sample are small and independent, so we will use independent sample t-test. Then the significant level is 0.025. So when we look at the alternative hypothesis, the sign is greater than. So it indicates that the test is right tail. For the degree of freedom, we get 5 and the critical value is 2.571. After that, we use the formula x as x1 bar minus x2 bar, and the answer is 1.8329. So after that, we use the formula and the answer is negative 0.7764. Because the value of the test statistic is negative 0.7764 and it falls in the non-rejection region, so we fail to reject the null hypothesis. Therefore, we can conclude that the mean fat content for all breed is higher than that for all the snake.
So the next objective to compare mean difference of fat content in rat and snake by using SPSS software. There are two types of wood, which is snake and breed. Mean of snake is 6.9076. For mean of breed, we got 8.3307. For the standard deviation of snake is 3.122. For the standard deviation of breed is 5.8247. For the t value, we got negative 0.776, and for the significant value for the one-sided is 0.223 and the two-sided is 0.445.
So next, the third objective of our mini project is to compare the proportion of item with high fat content between snake and rat. For this objective, we use the hypothesis about the proportion in two populations. For the null hypothesis, the proportion of high fat content in snake and rat are equal. For the alternative hypothesis, the proportion of high fat content in snake and rat are different. Then we calculate the sample proportion for snake and rat. For sample proportion of snake, we got 0.5314, and for the rat, we got 0.6408. The sign not equal in the alternative indicates that the test is two-tailed. For the significant level 0.05, we got the critical value of Z is negative 1.96 and 1.96. Then we calculate the full sample proportion by the formula given. Then we estimate the standard deviation by using the formula, and we got 0.19295. Then after that, we calculate the value of the test statistic. Then we get 0.3255. The value of the test statistic is 0.3255. Falls in the non-rejection region. Then we fail to reject the null hypothesis. As a result, we calculate that the proportion of high fat content in snake and rat are equal.
Okay, for the third objective, the software we use is SPSS. So we have two variables, type of food and high fat content. For type of food, one defined as snack and two defined as bread. And for the high fat content, one defined as fat over 10 gram, which is high fat, and two defined as fat under 10 gram, which is low fat. The chi-square test performed in SPSS did not find a statistically significant difference between the proportions of high fat items in snack and bread. So this result aligns with the manual calculation mentioned earlier, which also failed to reject the null hypothesis.
The fourth objective is to determine if there is a significant difference in the distribution of fat content categories between snacks and bread. So the first step is to state the null hypothesis, which is there is no significant difference in the distribution of fat content categories between bread and snacks. And the alternative hypothesis is there is a significant difference. So we use chi-square distribution, but to use chi-square test, the data should be categorical rather than continuous. So we convert our data into categorical data by creating categories based on ranges of fat content into low, medium, and high fat content. So we created a contingency table, but for high fat content, the expected frequency was less than 5, so we combined medium and high fat content into one column. So now we have a 2 by 2 contingency table. So we calculate the expected frequency for all the cells, and then we compute the test statistic value using this formula, and then we compare with the critical value with the 1 degree of freedom using this formula, and alpha significant level of 0.05, and then we get the critical value, which is 3.841. By looking at the graph, you can see that the test statistics value falls in the non-rejection region. Hence, we fail to reject the null hypothesis and state that there is no significant difference in the distribution of fat content categories between bread and snacks.
Okay, so for the last objective is to determine if there is a significant difference in the distribution of fat content categories between bread and snack. So we use the software, which is SPSS. So we have two variables, category and type. So for the category, we label it into 1 for low and 2 for medium plus high. For the type, 1 is for bread and 2 for the snake. So after that, we analyze the data, and then we get for the bread, the count and expected are same, which is 13, and for the snake also same, count and expected count is 13. So for the total, for bread and snake, we get 26. So for the asymptotic significant, for two-sided, we get 0.691.